lately is that I am having a computer issue to run it on pure hydrogen. We have a Toyota to sell. I selected it because the internet said it'd get 44 miles a gallon. And gosh, I could have brought that thing down here today and conned all of you. It did great in first gear, it did great in second gear, but in third gear it had no power. And that's the issue we've been having. Something about hydrogen, pure hydrogen,
Right. Okay.
that does not have the power. There's also a dead spot in hydrogen. Even the car that I'm talking about, we built the Nissan. When you change gears, there's a little dead gap, and I don't know enough to know what that is. And I still get a little back part. And once you get the torque back up, it does okay.
Is it turbocharged?
No, this is not.
Oh, it's not. Naturally aspirated engines with hydrogen have some inherent flaws. I mean, there's no way getting around it. But with turbo boosting, definitely, will probably eliminate those.
For guys, and y'all correct me if I'm wrong, I think I like to use this word every now and then, stoichiometric.
Oh, yeah. Yes.
PhD has to use a word like that every now and then. The fuel-air ratio for gas, I think, is 14.5 to 1. For hydrogen, it's 35 to 1. So if you use a pure hydrogen engine, then you either need a turbocharger or a supercharger. I went to a conference last year, Robert Napkin of Ford Motors, which is a big hydrogen man with Ford. They've been going back and forth themselves as to whether to use a supercharger or turbocharger. Quite frankly, I forgot which one they decided on because there wasn't that much difference in it. Now, I've had that to sell now at a performance place in Nashville for 6 months. Had it at another place for 6 months. He thinks they got it figured out, but I don't have the car back yet. So that is the issue with pure hydrogen. Now, we built another vehicle now, and I wish you could see this. This thing's nice. It's our vehicle that runs off nothing but sun and water. Now let me tell you how I do that. I do not put water in the gas tank. Please understand that. Okay? But while we do have a system at the university, here's how we run engines completely off sun and water. Now again, you may not like this system, but this is what works for me. First of all, we start with a 10 kW solar unit. It's attached to our building. Now again, I'm not going to tell you this stuff is economical. My philosophy is this. It's kind of like the Wright brothers flying that first airplane. By gosh, do it.
That's right.
And then somebody will make it better.
That's right.
And I'm not going to tell you my system is there, but by God, if I can do it, then it's just like the Model T.
Mm-hmm.
It'll get better and better. That airplane of the Wright brothers is not worth anything to anybody except the Smithsonian. But by gosh, they did.
That's right. 11 seconds.
And that's what I'm doing. It's showing you a system to run engines completely off sun and water. Now, how do we do it? We take the solar unit and we run it into the grid line. TVA, that's the big utility to the southeast, has a program called the Green Power Switch program. So everything that we produce with the solar, it's metered in the grid line. Now, when I got this unit, I told the person, I said, I want to charge directly, I want to run the electrolysis unit directly. And he said, run it through the grid line. I said, I don't want to run it through the grid line, I want to charge it directly. He said, no, you can still do it. I said, okay, I'm open-minded to talk to you. Well, I finally got it. It works like the banking system. You get your check on Friday.
Well? Oh, okay.
You get your check on Friday, or you put whatever $500 in, it goes in the same pot as everything else. But when you take it out, you still got the same amount. Now, admittedly, my solar is in the same pot as the hydropower, as the nuclear power, as the wind power or whatever. So I just do a millionth, trillionth as much as they do. Now, when I charge my electric truck, I hook it up to a meter, and I meter everything I use. Now, when I run the vehicle, I'll get to in a minute, off of hydrogen, we have an electrolysis unit that comes from Proton Energy out of Waterford, Connecticut. It produces 40 cubic foot per hour. So then, that hydrogen unit is run by the electric that come from the sun,
What you call it, proton energy?
proton,
Proton.
yeah, just like that. There's a coffee cup back there. My mouth is so dry I can't talk, but somebody bring me that. It's next to a
There's a
black
tap
cup.
right there, sir. Ice cold water.
Oh, good.
My comment.
That'll work. Excuse me. Sorry about that. So when the electricity then is in the grid line, we're just pulling it out like writing a check. Now, I'm here today. I'm not in the building that much. This research is an addition. My main job is I teach future agriculture teachers. You're familiar with the FFA organization. I teach those future teachers. I have only used 7,000 kilowatts, but I produce 62. So I've got 55,000 kilowatts in the bank. If I'd have done it my way, I'd have lost that the extra efficiency of that solar unit. Now, so when we run the electrolysis unit then, it comes out at 200 pounds of pressure. Well, when I first got the electrolysis unit, I wanted to go with a metal hydride tank. That's solidified hydrogen. And that's manganese,